All right. Question 1 is about the Runge-Kutta method for doing system of the ODE. So in fact, it's the second order Euler-Cauchy problem, but we can solve it directly. We know how to do. The change of variable should be y equal to the x to power p, and you can find the p and you can constitute the complementary solution. So, but we can solve this problem with converting this second order to the system of the first order ODE, which we have learned from Math2800. So as always, Z1y, Z2y prime. These are my favorite notations. So from here, Z1 prime will be y prime, which we have to write it in terms of Z1 or Z2. And Z2 prime here, which is equal y double dash here. But y double dash can be obtained as this fraction. And this fraction, it has y prime. So let's put it as Z2. This has y, so y should be Z1. And x can be left here. So this, I would like to decompose it because I want to see in terms of Z1 and Z2. So Z1 prime, Z2 prime can be written in terms of this matrix A times Z1, Z2, where the initial value is Y1 and Y prime, or Z1 or Z2. 4, 9 comes from this initial condition. So you've got this, and from here, you can have a look at the solution of tutorial solutions of this week, the typed version, and also the course note, that to see how it's possible to proceed. There is nothing new notion for you, but setting up the problem is important. So what I have written here is just what I felt that this is better, actually. I didn't do any numerical things with my hand, but I've done just last night some Sage Math. So I didn't do these things in yesterday's tutorial session, but they will see. But I did it last night, and I will show today for you, and they can see in the PDF later when we upload in the canvas. So z to the n plus 1, what? So this is not power, this is the notation. The n plus 1th term, actually. Z to the n is nth z. What is z? Z is pair of z1 and z2 plus the usual definition of the famous version of the Runge-Kutta, RK4. So z, what is the Zn? As I said, the pair of the nth term of the Z1 and Z2. Now, here's the important. K1 is Z1n, Z2n, and Z1n is itself can be depending on Z1, Z, and Z2, and depending on the X, independent variable, or T, okay? Z2n as well, okay? So I have written it like this, A times this. K2, if you understand K2, I don't need to explain K3 and K4 because it will be the same. So K2, F, I mean, what is F? F is the whatever on the right-hand side of this. But I have decomposed it, A times this. So F of first component independent variable plus h over 2. It can be t or x, comma, Second component or second input for K2 is this. This ends this column vector plus H over 2 K1, which is column vector. So this is a column vector with this one. All right. So F, say like this is the first one is this is H is a step size. So if this one is like just real number. It's not a vector. It's not a matrix. It's not a column vector, but this is a column vector. This is important to understand. So this is F. So here F is written here. Okay. Instead of this xn, you will substitute. So F is this guy here, okay, or here, okay. Anyway, instead of this xn, you will sub xn by this. You will xn plus h over 2. Instead of z1 and z2, you will sub this the column vector. The column vector, it will be something new z1 and new z2. So for new z1, you will add this one to here, and new z2, you will add this one to here. All right. So you're happy with this. Okay. So what we can do now, so K3 and K4 is given here. So in your course note, not lecture slide, course note. So Runge-Kutta has been explained to you, and it has been like the change of variable is like y prime equal u. So y prime equal u. Over there, there is two columns of Runge-Kutta for u, which is y prime, and for y. But it's slightly different. So you can have this one and whatever is in tutorial solution. So we will come back to this question later. We will finish question 2, 3, 4. We will come back and I will explain more in the Sage Math. All right. Question 2 is this guy that tells us why the numerical methods work. There have to be some condition on the step size. Now, all the new y's, new values for y, they are depending somehow to the yn. But there is a polynomial here, okay, p in terms of h and lambda. Y prime is equal to the right-hand side, which is written in the standard way, or at least in a way that we do programming. Y prime equal to f of xy. Now, so there are some explanations here. So, all right. So part A tells us that what's the condition RH lambda, which is like the same as P of H lambda for improved Euler. Before doing part A, what's written? PS is 1 plus S, okay? So Euler's method. So we can have a look at this one as well. And Y prime is lambda H. Okay, so Runge-Kutta, the order can be 1, 2, or 4. So if we have something like this ODE, so as it's written here, yn plus 1 will be like this. Now, when improved Euler theta, improved Euler, y prime is equal lambda y, f of xy is lambda y. So why this is happening? In fact, yn plus 1 is equal y sub n plus h times f. This is yn plus, and this f is lambda y. So h times lambda yn. So yn can be factorized from the right side. And we have 1 plus h lambda. So if we do one more, so we will have this guy, y sub n minus 1, another 1 plus h lambda. So if we do like n times from here, we will have y sub 0 and this guy n plus 1. So to see that yn plus 1 is not infinity, this guy here 1 plus h lambda should be less than 1. So you can stop here. This is your condition, but so let's investigate more. 1 plus h lambda is less than 1, bigger than minus 1. This question is important for your final exam. Minus 1, 1 plus h lambda, 1 plus h lambda. Okay. So h lambda less than 0 for h bigger than 0. So h bigger than 0 means it is forward Euler method. It's going to the h is positive thing and it's going forward. So therefore from here lambda is less than 0. Okay. But if h is less than 0, then lambda should be bigger than 0. Because we've got this condition from here. Now, let's see this condition. Minus 1, this guy, h lambda. Now, since lambda is less than 0, then I divide this inequality by lambda. So this will be h less than minus 2 over lambda. Okay. So we see that the space that we can choose step size should be minus 2 over lambda. Otherwise, it won't be convergent. Otherwise, the Euler method won't work. For example, y prime equal to minus 3, y times 3 times y. Lambda is minus 3, so h must be less than 2 over 3. 2 over 3, what's that? 6600. So you can't choose something like h equal to 7/10. So then see what happens. And yeah, I forgot to do numerical method for this. But we can, so it's not, we are not asked to do this one. I wanted to do that. All right, so let's see after this class if I can do in SageMath, then I will do, then I will send in the Canvas. So improve the Euler method. Yn plus yn plus, so h over to k1 plus k2, which is the same as formula. So k1 is this guy, k2 is the tricky one, xn plus 1 yn plus h times, depending on this k1. So what was f is lambda y, so yn plus 1 yn plus h over 2, lambda. So the first one, k1 is just this guy. So it is lambda yn. This guy is the tricky one. K2 is f. What is f? F is lambda times the second component, which is yn plus h times k1. So substituting this k1, so I will have this guy. So all of that have the yn in common. So after expanding and factorizing yn, I will get this parentheses. So from here, again, as in Euler's method, it must be this guy, absolute value of this guy should be less than 1. So by the way, you can see that 1 plus h lambda, this guy is this guy, e to the lambda h. It approximates this guy. To get the exact number, it should be until infinity, this guy here. All right, but however, we know that y prime lambda of y, the answer, the exact answer is C0 e to the lambda x. I'm confused. Okay, yeah, it's this. So from here, we know that this absolute value should be less than 1. All right, the Hume's method is the similar version. Okay. Okay, so question 3. The critical point is when we call the critical point if x prime and y prime equals 0. It is the same as the one that we have seen in the first question of the assignment. It sounds like what do we call there? Stable and unstable points. All right, so I've got like I have problem in like remember the special names. So when y prime equal f and when the right hand side is f for that solution, those important solutions they have some name. If you remember, please let me know. Huh? No. The name of the solutions. What was that? Okay. Yeah. So we found in assignment question 1, you found it and you said that which one is stable, which one is unstable. So those critical solutions, what was their name? Okay, x prime, whatever. So the equivalent version is this here, critical point or critical solutions. So the definition is which I have written it here. You can remember. So part A, this guy, x prime, y prime. So I would like to write everything like as A times xy, coefficient times xy. A is this guy, and the eigenvalue. So you know that to obtain the answer of this one is xy is C1 times eigenvector, something like this, e to the eigenvalue 2t plus C2 times eigenvector, corresponding eigenvector, e to the 3t. So the eigenvalues of the matrix A is this guy, lambda 2 or lambda 3 as the root of this guy. And so, fix this. All right, so you see that e to the 2t, e to the 3t, one of the eigenvalues are positive, then this critical point is unstable. In other words, if you have like a little bit from x equals 0 and y equals 0, if you have little bit difference, if you far away little bit from x equals 0, y equals 0, these e to the 3t, the e to the 2t, they will like fly, they will escape from this point. Okay, that's why if these were negative eigen -3 and -2, they for whatever t they could be convergent to the 0 for x to the x equals 0 and y equals 0. So what's the criteria? One of the eigenvalues, at least one of the eigenvalues is positive, then we are unstable. These critical solutions are critical point is unstable. X prime, y prime, the coefficient matrix is this one, part B. So I'm sure that you don't need to see this. How? So one of them is positive, so unstable. So x, y. So you see, again, this guy. But if, let's assume that this e to the 2t, the coefficient is C1 equals 0. If this is 0, so then we can say something about the stability of the 0, 0, provided that C1 is 0. Because C2, e to the -2t, we have negative number here. C is this guy, so I'm sure you can do it. Part E is this guy, a times xy. So see, I have written lots of details for you. Yeah. Lambda plus minus 3i. So this time is complex. So for complex ones, we will have a look at the complex eigenvalues. If the real part is positive, then again we have unstability. However, it will be unstable by circling, but anyway, it will be far away from the critical point. So 0, 0 is, but this time complex eigenvalue, the real part is 0, and we have just 3i. So this is stable, and since we have complex, it is somehow moving around. It will be something like either it will be like ellipse or spiral or center. Okay. Now there I didn't see some items to say that the details about the stability and unstability in lecture slides, but when the real part is negative and it's complex and the real part is negative, we have it is stable and it is coming and going to the like spiral, going to the solution or critical point. If it is real part is 0, then we have center. So I will wait. Otherwise, next week I will find it and I will bring it for you. Anyway, so the most important part is stable and unstable. The rest is like maybe optional. And also for stable, we should see that it's attractive or not. So when the real part is 0, we have stable, okay? It is center, but it's not attractive. To get attractiveness, the real part should be negative. Question 4 and the last question. So this guy, the trick of finding the critical point is, there is no trick, but to say that what it is, we can do this. So x minus 2y, I'm sure that you don't want me to see the details here. X equals 0 and y equals minus half. So 0 minus half, the critical point. Now, change of the variable. We do change of the variable. So for this little x, I decided to be, what do we call? Capitalized X or big X. And y little minus this guy, minus half. So when it is minus, I will choose this capitalized y to be y plus half. If this is plus, I will write this one is minus. So because, why do I do this? Because its little y will be y minus half. So if I substitute this guy to here, so if you don't want to confuse, so you can just have a look at here. So you can decide that little y to be negative. So because if I sub this guy here, this will be something like, so x is x, this guy, and this will be just 4 times big y. I don't want to see this plus 2, and I don't want to see this minus 1. So nevertheless, this system of ODE will be this guy. The coefficients 1, minus 2, 1, 4, it will be the same. 1, minus 2, 1, 4, x, y. Actually, this guy. So if I decompose it as multiplication of the matrix, will be this. So I'm sure that you don't want me to write y, lambda and lambda 2, 3, 2 and 3. So 0 and minus half is unstable. Part C, x prime, y prime, again, this. Now, so this time, again, we solve this one. What a nice number. 7/5, 19/5. So these are positive. So let's remember that capitalize x, capitalize y, we can do this change of variable. So this will be x prime, y prime, 1 minus 2, 1, 3. So 1 minus 2, 1, 3. So it will be here. 2 plus minus I. The real part is positive. So this critical point is unstable. Okay. All right. So let's go here. Yes. So what is this? This was the question of this year's Math 2310. Okay, so so last year you guys were lucky, yeah? So do you have Math 2310 now, or you don't have? Last year, 2 years ago. Yeah, I respect you. Then this, you see, so this is the question mid-semester of the question 2018 and also 2023 this semester. So see, this is beautiful. Y double dash xy prime. So we have this Euler's method. Let's start with Euler's method. So what is this is again initial value problem. It's second order. We can convert this one to this matrix. So how? Let's have a look at the solution. Z1 prime, Y prime, Z2 prime, Y double dash. Okay. So this is so from here Z1 equal to Y, Z2 equal Y prime. So as always. So if you write this one, then the rest will come automatic. So then Z1 prime, Z2 prime. What is Z1 prime? Is Y prime. What is Y prime? Z2. Okay. Here. Z2 prime equal Y double dash. So Y double dash comes from the original ODE. Y double dash comes from here. 4y minus xy prime. 4y minus xy prime. So, okay, you've got this one. So this Z1 prime, Z2 prime, 0, 1, 4 minus x, Z1, Z2. Where this Z1, 0 and Z2, 0 is 1, 2. 1, 2 or 1, 2. All right. So Euler's method for, so it says that try to give us, so y of 0. So we wanna estimate y of 1. Step size is 0.5. So you will do 2 step size for that. All right. So we've got this one. X0 is 0, or independent variable. Initially it is 0, which is here. Z sub 0, which is this guy here, 1, 2. So what is the Euler's method? Tells me that Zn plus 1, okay, equal to the previous one, which is this guy here, plus f. F is this h times f. H is half f. F is this guy here. See? Do you see my pointer? Okay, F. So this so you see that, so we apply 0, 1, 4. So x0 is 0, z1, z2 this time is 1, 2. So 2, 4. Okay, so we got 2, 4. So z1 and z2 is 4. So what is z1? Z1 is y. So y is 2. Z2, it's not important. 4 is not important. 2 is important one. Okay, now x2, so another step, x2, z2 equal to previous step result, 2, 4 plus h times f of new x. So new x is, it's been moved from 0 to the 0.5. Here, yeah, that's it. Yeah. 2, 4. So after doing this, 4, 7. So Z1 will be this guy. Z1 is this, Z2 is this 4, 7. But this one is Z1, this one is Z2. What was Z1? Again, Z1 was Y. What is Z2? It's not important. Y equal 4. All right, so, okay, here. Now, since you are very interested, Blanche, please go to this 10 hours ago. So this is a bonus for you. You can, so you cannot find even in Monash universities. Okay. So what is the Euler method? So this time is very advanced problem because so we don't have F. We don't have F or something else. It's written for everything. Okay. Let me see. So this is the Euler method that just I had this one like 4 years ago, but last night, so I didn't say these things like in the last year's Math2800. So this is the Euler's method. Mostly I will leave this one to you. So see, if this time we don't have H, step size, and the destination B. Over there, it was very simple because I wanted to help you to push you to do sage math, which I was unsuccessful, and it was like it was more like understandable. This time it is more like abstract. Okay.
How many people end up using Excel?
Huh?
How many people end up using Excel?
I'm not sure, but not few people. Okay, so this time it is input parameter. All right, so this one you see that, so is written 0, 0 because we have 2 dimension. System of the ODE, first equation, second equation. You can do it for first, just only 1 equation. You can do it for 3 equation. Okay, for example, Lorentz system. Okay, so you can see that you can study this. So I can so M is the length of F. And what is F? F is the right hand side, which I was writing for you. X prime y prime equal this guy F. First equation, second equation. So since we have 2 equations, the initial one is 0, 0 there as well. Y is this guy here, 0, 0 is like Z1, Z2. This guy here, Z1, Z2, or Y or Y prime. This F Y, I said that what it is. So length variables, 2 equations, and I prefer this condition. 2 equations, 2 variables. 3 equations, 3 variables. Lorentz system, the famous one. 3 equations and 3 variables. Okay, but the outside of this, I don't know how to do that. I can do, but I don't have time. So
is that underscore used in the variable in the folder? or underscore in range.
Where is that?
Third line.
Yeah, it's okay. This is K1. K1 is for you are making K1 is column vector. This time K1 is not one number. K1 is column vector. I cannot go to the iPad again. K1, if you remember, like matrix F, K1 is equal F. So matrix A times Z1, Z2. So it was like the result was something like column vector. Two things. So this is a list of the zeros, okay, for the way that I finally end up to work, how to write a list, produce, to generate a list of zeros is this. So anyway, but these are the trick of the programming tricks. You can do it, but K1 is coming from this F of by substituting the independent variable. The independent variable initially is, and it comes from this A plus I times H. Whatever K1 is this guy, and K1 also I forgot what to do, what I did here. Okay. So anyway, so so I will give this Python file. You won't use in your final exam. So you are just learning this one. So so this is the Euler method, and can I use the Euler method? Can I use here? Yeah. So this is the green part is Z2, the red part is Y or Z1. So you can have this one. All right. So it would be, so, okay. So A is 0, 0. B is 1, 2. So can I go here? So A is this 0 and B is 1, 2. So let's go here. 1, 2. Okay, and A is this one. T is the variable X or T. What is X? Just explaining this part. Variable, we have X1, X0, X1, which is X, Y, which is Z1 and Z2. Okay, so that is those variables. So when we write X prime, Y prime equals something, X prime, X and Y, they are depending variable. This is, I have shown it, this one here. So I was lazy to write X variable, Y variable. I just created in one shot. Okay, so the function, or I would call it Lorentz, because I wrote this one for the Lorentz system. So for Lorentz system, you can look up in the Wikipedia, and it is this guy. This guy, and it has this one. All right, so let's go back here. So you can call this F or Lorentz system. F is two equation. X, Y, this guy, Y, and this guy. So let's see here again. It is this guy. Okay. Or this guy here. Z1 prime equal to second depending variable Z2 or Y. Z2 prime 4 times first one minus X times second one. Again, 4 times first one minus X or independent variable times second one here. So then I write this. So that's the plot. The plot here is not so nice, but we can later find the nice one. So the Lorentz system, and I can find this guy. Okay, so this is the first list is about the x0, x1, x2, and it gives me three lists of y, y and y prime, or z1, z2. This guy is z1, z2, 2, 4 is same as this guy. Here, 2, 4, and 4, 7. This so the marking solution is not wrong. Okay, we confirm that it's okay. Okay, so now this is the Runge Kuta. I more or less explained the Euler's method, but I leave this one to you. What is the difference is, instead of K1, I have K2, K3, K4. Here is the same thing. Again, Y0, 0. Can we do it in one dimension Runge Kuta and replace the old-fashioned Runge Kuta? Yes, you need to get rid of this part. You need to make it like this, okay? But we don't do now. So Runge Kuta, no panic, everything is the same. Instead of writing K1, I have repeated K2, 3, 4. So you can do this. And the question one, x0 or a is 1, and we had 4, 9, if you remember. Yeah, 4, 9. So again, this guy, we have two dependent variables, Lorentz or function. I like to call it Lorentz function. So do you remember the function was like this? X squared or t squared. T squared is because of the Euler Cauchy. So we have been asked with step size 1/10 to do y of 2/10. So the destination point is not given to us here. Instead, n. So you can destination y of 1.2. So it is 2 twice. So if we do this, we see that so the solution given in the tutorial solution, it is right. We confirm it, okay? And this one we don't need. So 1.1. So what if I do the same job with system of the ODE Euler methods? Then I will get this guy. Instead of 6, I will get 5.9. So because Runge Kuta is more precise. All right. So as I repeat, you won't be asked to doing these ones in your final exam, but you can just have it. You should have something to show students in other universities. Yeah, okay. All right, that's the end of the session.
Thank you.
Okay, no worries.